So these are the equations, but what does these equations describe? What effect do you expect to see out of these equations that are different from a two-dimensional boundary layer? Okay. So first of all, if there is no pressure gradient, first effect is, I would say, lateral pressure gradient. So if you have a streamline going that way, so if you have a, let's say, UE, I should write QE, right, goes that way, and you have a high pressure here and low pressure here, that is, you have a transversal pressure gradient. So first question is, how do you expect the UE to evolve as it travels downstream? It should curve downward, right? Okay, so your QE downstream is going to be pointing downward. Now suppose you have a boundary layer that is exactly two-dimensional upstream. How do you think the velocity inside the boundary layer going to respond to this pressure gradient? So let's say I want to use the blue to draw the velocity inside the boundary layer. How is that velocity, how is that streamline that is inside the boundary layer going to respond to the same pressure gradient?
More.
It responds more. And why is that?
Lower inertia.
It has lower velocity or lower inertia, exactly. So the velocity is going to curve more, right? It's going to do like that. Which means if you look at the boundary layer profile here, you have a velocity inside the boundary layer that is slower and going down. Right? So okay, so now if you look at, zoom in to the point here, you have velocity that is high and pointing more horizontally, and you have a velocity that is slower underneath, even slower, and they keep rotating downward. So you have a boundary layer profile that if you look down from above the wall, it'll look something like that, right? So now that is one of the most obvious effects that makes the boundary layer three-dimensional. And this three-dimensional boundary layer has a coupling effect. It couples the boundary layer from nearby streamlines, right? Because the velocity here, so let's say you have a streamline that goes like this, another streamline that goes like this, and over a nearby point, you also have this kind of boundary layer profile. So what happens is that the velocity inside the boundary layer is going to transport some of the momentum and kinetic energy from a nearby streamline, from the boundary layer profile of a nearby streamline to here. So the different streamlines are now coupled, like the boundary layer profiles are coupled, they influence each other. Okay, that means in order to determine the boundary layer profile over here, you not only need the boundary layer profile upstream and also the outside velocity profile, you also need the boundary layer profile of a different streamline, of nearby streamlines. So that's one of the effect that is different from a two-dimensional boundary layer. So one is lateral pressure gradient. Okay, that causes the boundary layer to become three-dimensional and couples different streamlines.